Thank you.
Thank you. Good afternoon. For those of you who've been hanging in all day long to see all the Meet the Cloud work, I appreciate you hanging in there and sticking around to learn about data. There is no application without data, right? We all know this. At the heart of every program, everything that's done in computing, there is, in fact, a major data challenge and a set of data sources that need to come together to meet those applications' needs. In the next hour or so, I'm going to talk about data in Azure, the different offerings we have that together offer a complete set of capabilities for you to develop modern applications in Azure. I'll take this familiar frame from Scott's deck from this morning. We're going to be talking about big data, we're going to be talking about database services, and the other storage systems that we have in tables and blobs in Azure. But before I start, let me tell a little bit of the context about why this is so important, why it's so different than just simply lifting traditional systems and the way we've known to deal with data from the current generation of computing and what's different about the cloud. The cloud's really taught us really two different things about data. One is that all the information matters. It turns out all of it really does. The big search entities that are on the internet, what they effectively do is they take tiny little pieces of data in terms of what users are clicking on and asking for, and they composite it together into these profiles that they can sell to advertisers. This is a transformation between raw data, very tiny little breadcrumbs of data, up into something that's of value, information that's of value. The other thing the cloud's taught us is that all kinds of data end up mattering a ton. And certainly the phenomena of Hadoop and the ability to work through unstructured data is a piece of that. But the other thing that's of note is working with things like spatial data. The number of GPS sensors that are now proliferating in devices just continues to grow. Why is that? Because the location of things, the where of things turns out to be a very interesting data point. And so the platform needs to support not just the traditional standard relational data types, but truly needs to support all kinds of data. Other trends are affecting this as well. The technology to provide cheaper and cheaper storage as data gets cooler and cooler, in terms of it being super hot transactional throughput data versus data that's archived somewhere that may be gone back to at some later time to find some interesting information inside. That trend of cost changes dramatically as that data cools. Data volumes are a big part of this as well. There's now interest from businesses in capturing all information about their business operations and about their customers and their behavior, and using different kinds of services in order to try to get some value out of that. All of this really is about answering new questions to gain new insights into business. It's true in the search engine cases, but it's also true in some traditional businesses that have revolutionized things like the retail industry by doing a great job of capturing all of this operational retail data and looking for those insights and using those to change business practice. The cloud and data offers an opportunity for us all to gain that same kind of capability, for us all to go and gain those same kinds of insights and transform our own businesses. That's why data in the cloud is so important. Microsoft is focusing on this in a variety of different ways. First, we think about it as being enterprise ready. You have to have a data platform where you can operationalize the data and operationalize the information you're gaining out of it in a way that can be relied upon for your business process. It's very foundational. And as we are going to bring Hadoop into the ecosystem, we're going to make sure that it's an enterprise-grade implementation on Azure and on Windows Server. Connecting to the world's data. Increasingly, modern applications don't just talk to their own data, but they talk to the world's data. Things like what's going on in social analytics, or simple address correction, or cross-business data exchange. All these things are becoming super foundational and important to how data is managed and used and leveraged in modern applications. In Azure, we're building a marketplace to allow people with data to come and offer that data to our customers, to our collective customers. And last, it's about insights. We have to have a system where the average user that has business questions can go and gain insights into the information that's derived from all this new data and all those new data sources with simple and familiar tools, simple methodology, and all a way that's done that does not require IT to build and rebuild and rebuild for every question that's ever asked. In Azure, we talk about these 4 major areas. And over the next hour, we'll talk about each of these 4 areas in turn. We'll start and we'll speak to using virtual machines and encapsulating SQL Server and what that's good for. We'll move on to the database as a service, the Windows Azure SQL data service. Then we'll talk about Azure table storage, and finally we'll talk about blobs and the services that we're building around Azure blobs. So to start, let's talk about SQL in a VM. SQL Server in a VM, I believe you've seen the demos a couple times today to show the different kinds of pre-canned VMs we're offering as part of the new infrastructure as a service Azure offerings. Here too, SQL participates, SQL Server showing up as an offering there. But what is it? Well, it's SQL. And by being SQL, it's fully compatible. It is a full package product brought forth in a VM environment. What that means is that you can allow us to take on the TCO cost of operating and managing the majority of the activities around keeping that VM running and offer you that compatible VM for you to use at your own pace. That flexibility and control are super important here. Where you want to run that VM, if you want to run it on-premise, in your own dedicated private cloud infrastructure, whether you're using a consolidation appliance from us, or whether or not you're using the VMs in Azure, that symmetry of the full package product and that compatibility is key to the kind of agility and control that you need. And all this is done, of course, on the managed infrastructure. You don't need to know what happens when we have a network switch failure and we've needed to hydrate a bunch of VMs in another part of our data center. You don't need to worry about what happens when a hard drive fails. You don't need to worry about what happens when some internet connectivity has an issue in one of our data centers. We manage the infrastructure and provide you that service. And we do it at scale, which will provide, in turn, you offer savings in terms of how you are able to consume those offers. As we've been going through the TAP programs for SQL Server running in VMs, we've seen a bunch of very common patterns emerge. Moving existing applications, Tier 2, Tier 3 applications, have been the first to go, where companies have seen the value in taking these applications and migrating them into the public cloud infrastructure and running them at a lower cost of ownership. This frees up IT, not just the people, but the resources in the hardware to focus on other projects. And it allows them the notion of continued expandability as departments have wanted to get after new Tier 2, Tier 3 applications. We've seen a major trend around develop and test. The agility you get by spinning up a VM in a matter of moments to be able to begin to build an application is way different than what it takes to spec out a project deeply enough to understand how big a piece of hardware you might need in production, and then order that piece of hardware, get that in, put it together, power it, feed it, all that stuff. That going from months, potentially, of work down to moments, obviously is a game changer in agility. Backup database to the cloud. Being able to take databases and back them up into the cloud service is another thing we've seen a lot of customers start to do, providing another layer of availability management for their applications. And finally, we've started to see some extension of their on-prem systems into the cloud. Sometimes refer to this as bursting into the cloud, this meme of having an infrastructure on-prem that's being used in sort of the day-to-day business operations, where some need comes that exceeds that on-prem capacity, and they're able to roll very quickly a set of infrastructure out of Azure to run that capacity and then spin that down very quickly as that peak ebbs. So over the course of the rest of the talk, we're going to stitch together an entire end-to-end scenario that puts together an application that one of our fictional Contoso companies has to show how all the various pieces of storage all tick and tie and stitch together. I'd like to welcome David Robson up on stage to come start walking us through it.
How you doing?
Expect me that way.
So good afternoon. How's everybody doing today? Pretty good? Yes? Awesome. So what I'm going to do today is show you first this application called Contoso Expense Reporting. I think most of us have used applications like this in our companies today. And what this application allows us to do is submit expense reports for different expenses. And what I'm going to do is show you this application, and then we're going to continue to extend this application throughout today's demos. So first, let me go ahead and create a new report. And let's just call it TechEd, since that's where we are. And let's call it Travel. And let me go ahead and add a new expense. Let's call it Air. And let's call it my flight. And let's call it Blue Yonder Airlines. I'm not sure if you guys know that, but that's another fictitious Microsoft company.
We have a few of them.
We do. It gives us the ability to not always use Fabricam and Contoso and all those other great companies that we go ahead and work with. I'm going to go ahead and save that in a draft. And then here we go. So this application is running on premise. It's running on a SQL box sitting down here. And I can go ahead and just look at that database very quickly. And here it is right here. It's expense. So the goal of this demo is to take this application and migrate it up to the cloud running in SQL Server 2012, running in a virtual machine. So in order for me to do that, let me go ahead and provision myself a Windows Azure virtual machine. To do that, I'm going to go ahead and navigate to the Windows Azure Management Portal. I'm going to click New. I'm going to click Virtual Machine. And I'm going to say From Gallery. Now, if I just zoom in here for a second, look at all the different options I have. I have SQL Server 2012. I have Windows. I even have things like Linux, So I'm going to go ahead and choose the SQL Server 2012 Evaluation Edition. I'm going to click Next. And I'm going to call it Contoso SQL VM. Let me make sure the name is not being used. It looks good. Let me type in my password. Type it again for good measure. And since Contoso is a very large company, I'm going to choose a large VM to host this. I'm going to go ahead and click Next. I'm going to type in my DNS name. Perfect. I'm going to use an automatically generated storage account, and I'm going to locate it in the West US region. The next thing I'm going to do is create what's called an availability set. An availability set is also known as a fault domain. This allows me the ability to have multiple machines behind this, so in case one machine should fail, my application continues to run. Let me go ahead and click OK. And here we go. In a matter of moments, I will actually have a fully functioning SQL Server 2012 running in a VM without having to install anything, rack anything, buy anything. It's just a matter of this service that we're being provided. Since this takes a few minutes to configure and provision this, I already have one that I've already pre-baked. And we could see it right here called SQL 2012 VM. Let me go ahead and take a quick look at that. So what I needed to do before I was able to go ahead and work with this was I needed to configure some endpoints. The first endpoint is the remote desktop endpoint, which will allow me to RDP into it. And the second one is the SQL endpoint. I've opened up port 1433, which is the TDS port, so I can go ahead and use SQL Server Management Studio to go ahead and connect up to it. Let me go ahead and just go back to my dashboard and actually connect to the VM just to show you that it's an actual version of SQL Server 2012. There we go. OK. And here it is. So let me just refresh the database node to show you that there is, in fact, no databases on this. But I have a fully functional SQL Server right here. The next thing I'm going to want to do is I want to begin the migration of my database from my on-premise up to this virtual machine. So to do that, I'm just going to grab the endpoint. I'm going to go back into SQL Server Management Studio. I'm going to go ahead and connect up to it. Let me go ahead and paste that in. Change it to SQL authentication. And call this SQL user with my password. And there we go. Perfect. So right from within one SQL Server Management Studio, connected to these two different these two different servers. The next thing I want to do is I want to actually migrate this database over. It's a very, very simple task. In order to do this, I'm just going to right-click. I'm going to go to Tasks, and I'm going to go ahead to Export Data to Your Application. Those of you might remember that we added support in SQL Server 2008 R2 for this notion of something called a DAC pack. A DAC pack being a single unit of deployment for SQL applications. In 2012, we've added to that and extended it and created something called a backpack. You can look at a backpack as being the same thing as a DAC pack, but containing all the data. I have two options here. Option number one is I can go ahead and export this backpack, and I can save it to my local disk, or I have the option of saving it up to Windows Azure. In scenarios where I want to save it up to Windows Azure is if it's a very large database and it's going to take a considerable amount of time to restore. But for today, since it's a small database, I'm simply going to save it to my local disk, and I'm going to call it expenses.backpack. I'm going to go ahead and click Save, click Next, and then Finish. And in a matter of moments, it's going to go through all the entire schemas on the database, extract out all the data, and give me this one unit that I can go ahead and use to deploy. I'm going to go ahead and click Close. I'm going to right-click on my target database. I'm going to say Import Data to Your Application. And I'm going to go ahead and choose that same backpack that I had before and restore it and transfer the database over. Let me go ahead and click Next. It's already figured out. It knows that I'm connecting to a SQL Server and a VM or an on-premise version of SQL Server. And it's gone ahead and set up the data file and log file path for me. And it's looked at the backpack, and it knows that the database name should be expenses. I'm going to go ahead and click Next and Finish. And I'm going to give this a second to restore. And as this is going, let's go into Visual Studio and actually take a look at this expenses application. And here we are. What we're looking at is the expenses application, which is just a typical MVC application that I'm sure many of you have created today. In order for me to go ahead and migrate this, I simply, yes, I'm going to say it, I simply need to go ahead and change my connection string from my on-premise box up to the one I have running in a virtual machine. To do that, let me just go ahead and get rid of all this, add a quick code snippet, tab, and go down to my VM connection string, which I have all ready to go. And notice I've just changed connection string to SQL 2012vm.cloudapp.net. Let me go back to SQL Server Management Studio and make sure that my restore is completed, which it has. Perfect. I'm going to go ahead and click Close, and let me hit F5 and just make sure my application runs. This is a best practice just because it'll be very hard to debug this if I deployed the app to Windows Azure and all of a sudden I had made a mistake. If I log in as user, if everything went smoothly, I should see my expense report that I saw a little while ago. And there it is, TechEd. So I'm going to go ahead now and deploy this actual website up to Windows Azure websites. But since this is something I'm sure you guys have seen all day today, let me go ahead and start that, and you can go back to the slides and continue on.
Fantastic.
Slides?
There we go. So SQL Server running in a VM in Azure, you saw it live in terms of the demo, provisioning the VM, and then moving the database over. You can actually do that right up into Azure Blobs. You can do it directly. But after he showed you that the VM was in fact there through RDP, he then was running his on-prem tools, SQL Server Management Studio and Visual Studio, all on-prem, but continuing to manage and interact with these cloud-based VMs. So now let's just talk about the other parts of the journey of what it means to use the cloud. Infrastructure as a service is one thing, but the real shift is coming as we all move into a PaaS world and as we move into platform as a service. Windows Azure SQL Database is the relational platform as a service. It's a data platform offering that provides relational data capability, including just right over TDS, as a managed platform as a service offering. By design, it's highly scalable, it's highly available, and it has global reach. We run in all of our data centers. It's configured automatically to have multiple replicas and HA and backups as just part of the service. And it's fully managed by us. So as we improve it and add new capabilities and features, move the product forward, You get those new capabilities as we light them up, and we migrate everybody along. So we're managing everything from that part of the application tier on down in through the infrastructure. So all the patching and feature improvements and all those kinds of things end up as just taken care of as part of this fully managed service. It's built inherently to a scale-out design, which means that the new cloud design point is, in fact, scaling over lots and lots of commodity systems. And Windows Azure SQL Database is, in fact, built around that design point. It's also important, though, that we bridge you from where you are today to be able to take advantage of this new database as a service capability. The tools that you use to manage and program against Windows Azure SQL Database are familiar and consistent. Literally, SQL Server Management Studio and Visual Studio know how to let you write development for the new platform as a service. And then the portal, of course, and manage.windowsazure.com gives you the kind of capabilities you need to manage and oversee your database as a service subscription. So now let's take the next step in our demo. We'll take the existing SQL Server database application and we'll move it to Windows Azure SQL Database. David?
Perfect. So while you guys were listening to Quentin, I deployed the application. We can see it running here as contosodemo2.azurewebsites.net. So now it's fully running in the cloud. So the next step, as Quentin pointed out, is to migrate the database from SQL Server running on a VM to the Windows Azure SQL Database. So to do that, let me go back to the portal. Let me close this quickly. Let me go back to the portal. And I'm pretty sure you guys know where I'm going here. Let me go close that published profile that I had downloaded. Let me go back, and this time I'm going to click on SQL Database. I'm going to click on Servers, and I'm going to create a new Windows Azure SQL Database. I'm going to have my login name of Azure Admin, and my password. And I'm going to leave it in the North Central US region. Notice the new portal, I now have a checkbox that allows me to allow all Windows Azure services to access this server. It basically punches a very tiny hole in the firewall so that Azure applications can go ahead and hit this database. I'm going to go ahead and click the checkbox and just give it a second for it to go ahead and provision my new Windows Azure SQL Database server. And there it is. The next step, since I want to go ahead and deploy this database, I need to go ahead and configure my firewall. And I'm just going to go ahead and open it wide up. I like to run with scissors, so, you know. I got one laugh on that one. I got more for you throughout the day, so hopefully I get a couple more laughs. Let me go ahead and click the checkbox, scroll down, and click Save. So now I've gone ahead and opened up the firewall. So the next thing for me to do is to go ahead and take this database and move it from the VM and move it over to this new server. So to do that, first let me go ahead and go back to servers and copy out the endpoint. You Control-C that. Go back to SQL Management Studio, connect to the database, Control-V, Azure Admin, with my super secure password that I'm sure somebody can guess if they wanted to. I'm going to go ahead and click Connect. Now check this out for a moment. Right here in one single tool, SQL Server Management Studio that you all probably have installed on your laptops and desktops, I'm connected to all three. One, SQL Server 2012 running on-premise, SQL Server 2012 running in a virtual machine, and also Windows Azure SQL Database. And that's pretty rockin' fantastic right there. So let me go ahead and open up my databases, and notice I have nothing. But remember that same database artifact that I had before, the backpack? That same artifact I can use to go ahead and deploy to Windows Azure SQL Database as well. When I had done the export, if there were any incompatibilities with Windows Azure SQL Database, it would have alerted me and thrown up a warning for me. So I simply need to go ahead, right-click, say, import data to your application, point to the same backpack that I had before. Here we are. Click Open, click Next. And I get to choose the database edition. Notice, once again, this time it's not asking me for my data file and log file. It's simply saying, what edition of Windows Azure SQL Database do you want to go ahead and deploy to? Let me go ahead and click business and a 10 gig database. Since I know, Contoso, it's a huge company, it's going to continue to grow. I'm going to click next, click finish, and this is going to go ahead and begin to deploy this out to Windows Azure SQL database. I almost said SQL Azure, notice, almost. So the next thing to do in this part of the demo is to go ahead and modify the application to point it to Windows Azure SQL database. So back to Visual Studio we go. We go back to that same connection string. And let me just enter in one more code snippet. And this time choose Azure connection string. Go back to the portal. Grab my server name. Back to Visual Studio. There we go. And let's just make sure that that completed, which it did. Let me go ahead and close that. And now that I've already published it, I can just right-click and simply go publish again. And what it's going to do now is not going to go ahead and republish the whole entire application. It knows that all I've done is change my web.config file. So that's the only change it's going to go ahead and push up. So here we have it. And if I go back to my reports, I can see my TechEd expense report that I had created earlier that went from on-premise SQL Server to SQL Server running on a VM, and now is running within Windows Azure SQL database.
Great.
All right. Couple claps.
Back to the slides. Thank you. So now we've taken this application. We've brought it off-prem first to gain some agility and savings by running it in infrastructure as a service. And now we converted over fully to using all of our platform as a service. So to give a little bit of insight into how Windows Azure SQL Database works, we'll take a moment and talk about how the infrastructure is built. At the foundational level is Windows Azure. And Azure SQL Database runs as a service on Windows Azure. And that the fabric underneath us provides us with the machinery and the ability to monitor and replicate instances and the failover mechanisms and the load balancing, all that stuff that's required to run a service really of this scale. Building on that, every node that participates in Windows Azure SQL Database runs a set of replicas for any number of given databases. And so there's a primary. Every single database ends up with a primary, and then at least two secondaries. So we can survive we have fault tolerance to survive failures in the hardware and the infrastructure. We also, of course, run backups in these things to provide additional levels of guarantee in the service. On top of this, there's a gateway that literally takes the TDS connections and figures out, based on what the fabric is telling us, where to go to service the requests that are coming in. This ensures that the primary is the one that's interacted with so that you get the right kind of replicated behavior. It also opens up new possibilities in the future for how we manage traffic overall coming into Windows Azure SQL Database. One of those coming capabilities, well, it's already come. We shipped SQL Federation earlier that allows you to start to scale your database by configuration. SQL Federation takes the T-SQL syntax and extends it with new constructs that let you program to a more scalable version of a database. Once you've programmed to that construct, scaling the service becomes a matter of configuration options. You're literally able to add additional capacity to service your needs by going into the management portals and configuring additional capability right through the management portals as configuration options. You may want to do this because of just general data size. Any given single node in the Windows Azure database infrastructure will be limited in terms of how many gigabytes it's going to be able to handle. And by using Federation, you get to pull together more and more database servers to give you more and more scale. It also gives you concurrency and throughput. You actually put more machinery in place to handle a load of many thousands of concurrent users running against any particular database application. And all this happens once you've programmed to the Federation syntax. The platform as a service takes care of this aspect of scalability. It even allows you to dynamically partition and add that additional scaling without incurring downtime to your application. It literally is as easy as going in there and telling the service you want to have additional capacity applied to this particular database instance. So let's go ahead and look at how we convert over to that now in our fictional expense report.
Perfect. All right, so the first thing I'm going to go ahead and do is create a new Windows Azure SQL database. So let me go ahead and right-click, say a new database, and let's call this Contoso Fed. Contoso for our famous company, and Fed for Federation. I'm going to go ahead and click Execute, and here we go. We have a brand new database. The next thing I'm going to do is I'm going to open up a T-SQL script that I had written previously and show you what that looks like. Open Contoso database, open. Let me hit F5, and then actually, as this is running, walk you through what exactly doing. So the first, we're seeing some just normal tables being created. When I go ahead and create these initial tables, they're going to be created in what's called the federation root. So imagine a federation root as being like a master database for the federation. If you want, application-specific data that you don't need to get within the member databases, that's the kind of data you would store up in the federation root. If we scroll down a little bit, we'll actually see where we create the actual federation. And it's right here. So let's zoom in on that. So notice I'm saying create federation, user expense federation, and I'm specifying a user ID, which is an integer, and I'm going to do a range partition. What this is going to allow me to do is, when I go ahead and create my tables, I can specify this federation key, and it'll partition these tables across the member databases based upon what value is in the user ID. If we look at how I actually create a federated table, notice that there's a little additional piece of syntax that I'm specifying, and I'm saying federated on user ID, which we previously created, equals user profile ID, which is inside the table here. Now notice one other thing I had to do. Notice I commented out the identity part. Identities are not allowed as inside federated tables, and you might ask why. And the reason is that you don't want to have some sort of ID collision amongst IDs inside your federated database tables. If we scroll down, we'll also see one other type of table, which is right here. And this is considered a replicated table. So this table will exist in each one of the Federation member databases. This is things like reference data that I need to do lookups and joins and things of that nature. At this point, it's completed with errors. So let me go ahead and take a look here and just see what's going on. And while I execute this, let me go ahead and open up one other script that I want to show you in the meantime. And this is the actual federation split. So notice that I have a couple different options. You mentioned it's just a configuration option. Notice I'm saying, down a little bit more, right here, perfect. Notice I'm saying Alt Federation, user expense federation, split at user ID equals 40. Now what this is going ahead and doing is it's going to instantiate a split. The system will automatically orchestrate the splitting of this one database into two, and it will keep it online and transactionally consistent throughout the operation. So I don't have to worry about going ahead and taking my system down and wait until this completes. It's a completely online operation. If I now go, so that was one way to go ahead and do it. Another way to go ahead and do it is to use the Windows Azure SQL Database portal. So if I go back to databases, notice I have my Contoso Fed database right here. If I go ahead and click on my manage URL and open in a new tab, and let me go ahead and log in, Azure admin, type in my password, and log on. Disregard the Microsoft SQL Azure logo, please. And here we are connecting. Just give it one more second. Perfect. And my federation is not showing. Hold on one second. Let's just go back here. That completed. Let's just hit F5. And if this demo would have worked correctly, you would have noticed right over here a box that said Federation. I would have been able to kick off the split operation right from within this portal.
Are we connected to the right thing?
I believe we are connected to the right thing.
All right, we'll let you look at that. Let's go back to the slides.
Perfect.
But what is important here is that it is, as he said, it's a metadata operation, right? He did alter on the table, which we've also instrumented through the portal, so that you can go into very easily. And the punchline, if I'll steal it in case we don't get to it, is we do the click and split, which effectively now takes a federation, a single instance that we have on the federation, and splits it across multiple nodes. We have customers that are in production on this today and using it because of the guarantee of where scale is going in the future for them. Samsung, which is obviously a large consumer electronics manufacturer, is such a customer. They have in their modern generation of TVs, they call smart TVs, a set of infrastructure that literally calls back into an application they're running that uses Windows Azure SQL and federations to be the data store for each of those television sets. It calls home to check on firmware updates and application updates. If anyone's used these TVs, you'll know that there's an app ecosystem that's part of now the television where you can do different kinds of things, over and connected to the internet. Today they have over 4 million smart TVs supported, and of course their aspirations for market share well exceed that. And as they're continuing to grow, they know they've built on a pattern, developed their application in a way which will allow them to continue to scale usage. Right now they have about 500 requests per second. When they get to interesting peak hours as things happen across the globe, they're globally deployed. And they know that they're basically immunized against future capacity and scalability requirements. Another service we've built around Windows Azure databases is data synchronization. Here we're lighting up a whole new set of scenarios where you can synchronize tables from on-prem SQL Server, from SQL Server that may be in VMs now as part of Windows Azure infrastructure, and things that are in Windows Azure SQL databases that allow the synchronization of these tables across. And this isn't true just within your own enterprise, but it can work also across enterprise. This opens up a whole new set of data flow capabilities that are available as scenarios that are being used for modern applications today. So this works, again, on-prem and off-prem, and is configuration driven. You go into the portal, and you can set this thing up based on the subscriptions to the databases you already have, or set up new ones. And the service also is a managed service, so the software changes we need to make and continue to evolve and improve, add features, again, you get seamlessly as we update the service. And it also scales elastically as your usage of it continues to grow. Another service we're bringing online in order to pull forward the whole data platform and reimagine it as a continuous whole in Azure is SQL reporting. Here we've really focused on the ISV scenarios, those folks that are building for the enterprise as custom applications, or for ISVs building for the enterprise, solutions on data using the database, but then now need to do reporting as part of their application. So we're building that reporting capability obviously as a cloud service. It too will scale on demand. In fact, it'll just continue to farm out additional capability as your reporting usage grows and changes. But just like we've done with the database, we're providing that familiarity of the existing tools and programming model, so you're not completely shifting gears. You're able to capitalize on all the great things that you've learned over the years in using on-prem SQL Server reporting services. All this, of course, is packaged together in an offering that you can then figure out how to give the right kinds of users access to those reports as part of your application, as part of how the application is used. Did we get the federations going?
Sure, you want to see it?
Let's go back to that real quick.
All right, perfect. Here we are. So notice that we now have the federations listed there. I can see my user expense federation. What had happened is I think I logged onto the portal a little too quickly before the script had completed. But now I see it here. And I can simply go ahead and click on the federation. And I can see that I have one federation member. And in order to do this online split, I simply need to click on split. And click to split. And type in 40 and go ahead and do the split. And it's going to go ahead and start that operation.
And so that'll take a few minutes, right?
Will.
Can we get back to slides, please? Because what's going on behind the covers is we're orchestrating that split and then moving around the data that's within that partition over to the multiple partitions. And we're doing that as an online operation. So the service is very careful orchestrating that work so as to not impact the availability of the application as a whole. So we've talked about SQL running in a VM as part of infrastructure service, fully compatible, Elasticsearch in that dimension. And we've also talked about Azure SQL Database, which really is truly a platform as a service, and the new set of capabilities such as federation for the right programming model to get that scalability, synchronization as services built around that data platform capability, and then reporting that we're building around the database as well. So you see we're continuing to invest in Azure SQL Database and broaden how complete that data platform is, but building that really truly as platform as a service along the way. The next thing to talk about when we talk about Azure storage capabilities really is Azure Table Storage. Azure Table Storage effectively is a so-called NoSQL data storage. It's a key value pair storage system that has a hierarchical key value pair store and then REST APIs to program against that. Of course, we've done all the work in the .NET languages to allow very easy entity kind of programming against it. And we've also provided the infrastructure so that it's geo-replicated and fully managed. Here, too, like our other past offerings, the service is fully managed. As we continue to improve the service, add new features, etc., we upgrade the service underneath transparently so that you just get the new benefits as they roll through our data centers. Here I have a little example where I have a table, a Azure table called Movies, and within that I have a bunch of entities, Star Wars Matrix fanboys, as different entities within that table. We'll take a quick programming example of this before we move on to blobs. In my top section, my top snippet, I effectively created a new entity that's going to be in the movie table. And in there I have a partition key which allows me to build a hierarchy and sub-range within that table, and then a row key which will be unique into that partition, and then a bunch of data. And that data, of course, at that point, obviously up to you how semi-structured you want to be. We have customers that are putting incredibly large values inside those entities. And then in the next code snippet, you see where I'm retrieving it back. So I know that I'm after the movie table. I know which partition key I'm looking in, and I'm just taking the first entity that comes back out, the first row that comes back out. That's how easy it is to program against Azure Table Storage. And that service, of course, has the same scalability and elasticity that you'd expect from the rest of how we're building our Azure platform services. So that we'll move on to Azure Blob Storage. Azure Blob Storage is fully unstructured data storage. It literally is blobs that are managed completely within the Azure system. Again, it's another managed service. We take care of the software updates underneath the covers. Insofar as we build new capabilities and features, you just get the advantage of that as we roll that through the data center. And it's an incredibly scalable service. We have customers now with tens of terabytes, up to 100 terabytes of storage per account. Any particular blob can have hundreds of gigabytes inside. And the same programming construct that we've been talking about, the REST API interaction model, is available here too for Azure Blob Storage. Azure Blob Storage also has geo-replication for disaster recovery. It's actually even part of how you sign up and subscribe to a new blob storage is you ask for it to be geo-replicated, and you ask for that part of the service as part of configuring your subscription. And from that point forward, the geo-redundancy of the data is taken care of for you automatically. So here in our fictional Contoso expense reporting app, we have a pretty good use for, which is the receipt attachments you want to put in expense reports. And here it's a natural choice to use blobs to store those files. So let's go ahead and take the time to integrate that functionality into our demo app.
Perfect. All right, so the first step to do this is to actually go ahead and create the storage account where my receipts will actually go and live. I'm going to click on New. I'm going to click on Storage. And I'm going to click on Quick Create. And I'm going to call it Contoso Receipt. And it's going to be inside the West US region. And notice, as Clinton was pointing out, I have enabled geo-replication automatically set. So now what's going to happen is behind the scenes, it's going to create another blob store, another storage account in another region other than West US. So in the case of a failover will automatically happen, and my application will continue to run. Let me go ahead and click Create Storage Account. And as this is creating, let me go back to Visual Studio and start to add support for that in my application. So the first thing I need to do is I need to go ahead and add a reference to the Windows Azure Storage Client. I also need to get the storage client. You recall back in the day when you were a strapping young developer, you'd have to go find the SDK, download it, install it, and do all that crazy stuff. But today I can simply use NuGet to go ahead and install that. So I go to Tools, I go to Library Package Manager, I go to the Package Manager console, and let me switch to my local storage, and let me go ahead and simply install it. Windows Azure .storage. Let me just make sure I typed that correct, which I did. Now, when I go ahead, and if you were watching the screen, you would have noticed that my references flashed really quickly, because what it did was it went ahead and downloaded the client libraries that I needed to. It added it to my project and added a reference to the libraries automatically for me. The next thing I need to do is to add a couple code snippets to actually add the support of the ability to actually attach the receipt and store it up into the blob store. So the first thing I need to do is to modify some of the views. So let me go to Reports, let me go to the Editor template, and open up this guy. Now, for those of you sitting there saying, okay, is this something new I need to learn? What is all this stuff you're doing? This is just ASP.NET and C#. This is familiar to you. If I can do this as a program manager, you guys can do this as developers. So let me go ahead and do that. Tab. And there's that little snippet of code. Notice I'll have a little upload progress visual display. The next thing I need to do is actually add the form that will allow me to select my expense report item. So let me scroll down a little bit more, and let me put that right here. Attach form, tab, and this is the actual form that will pop up to allow me to browse and go ahead and upload it. And then finally, let me go ahead and modify the controller since it is an MVC application. Let me go to the control, let me go all the way down and just insert another method to actually do the upload. Let me just go ahead, attach method. And notice this code looks very similar to the code that Quentin showed you on a slide a little while ago, where we're going ahead, we're finding the container, and we're going ahead and setting the blob and uploading it from a stream. Perfect. Now that I've gone ahead and done that, I need to go ahead and tell my web config file about my Windows Azure storage account. So if I scroll down a little bit, I'm going to add one more snippet right here. And let me put in my storage account info. And notice my blob endpoint is contoso receipt.blob.core.windows.net. At this point, I need to go back to the portal, and I need to get my storage key so I can actually go ahead and authenticate and upload this. So to do that, let me go to contoso receipt and click on Manage Keys and copy this out. Close that, and let me go back to my application. Go all the way to the end and just add that. Account key right there. Go to the end, paste that in, and go ahead, right-click, and publish it. And while it's publishing, I want to show you one additional thing. Let me click Publish. Let me go back to the portal for a second. Notice I have something that says Monitoring Chart Unavailable. Well, let me go back. I have the ability to configure monitoring on my application, so I'm going to go ahead and do that. So if I go ahead and configure, notice I can go ahead and monitor my blob store. I'm going to click on Minimal. So what this is going ahead and doing is it's actually going to start logging different diagnostics about my application. And by setting this on the blob store, I'll be able to see the files coming in, the files going out, what the data ingress and egress is, and it'll be able to help me to manage my application a little bit better. If I go back to my Contoso expense application, go back to my reports, and I open up my TechEd expense, and go ahead and click Edit. Notice I have a new icon there, a little paperclip that will allow me to go ahead and attach my receipt. I'm going to go ahead and open it up. Let me click Browse to my receipt. I should have some receipts on my desktop. There we are. I'm going to go ahead and click Open, Submit. It's now uploading it to the Blob Store. Give it 1 second. There we go. One more. So it was a very large receipt. It was a very expensive dinner, so it's going to take a couple more minutes to go. Just 1 more second. It's thinking about it. The demo gods are not being happy today.
Well, but there's only been a couple minor glitches.
It's just a couple for us, yes.
Yeah.
You know what? Let me hit F5 one more time. And let's do it one more time. Receipt, open, let's submit it. There it is. Took a little bit quicker that time. And notice when I click on it, it's going to go ahead and load this image from the Blob Store.
Looks like you didn't sign that.
That's how I,
That's how you roll.
That's how I roll, right? So let me just go ahead and save and submit. And there we are. We're done with this part of the Contoso Expense application.
Great. Thank you so much. So what you saw there, I mean, across that whole range of developing the application, we're talking dozens of lines of code is all it was. And there's no configuring a server where, oh my gosh, I need to have these receipts put somewhere. I need IT to stand up a new SMB share, so there's somewhere for the application to put them. That doesn't exist. I need to provision enough capacity as we do an acquisition and maybe grow Contoso into Fabric Chemicotoso or whatever the merged company would be to reach that level of scale and global availability. That's also something that Azure just does. This whole meme of developing applications and bringing them up into the platforms as a service and taking advantage of the global scale and the aggregation that we're doing for that, of course, is truly transformational to business agility and scalability. There's another piece of this that is around big data that we talked about relative to Hadoop. Hadoop is an effort to really give people a programming model over large-scaled unstructured data. Well, of course, it works over any scale of unstructured data, but it was advented by companies who had very, very large data problems to work with. And they had data that was not even born as records. It was born as streams, log streams, in fact. And our effort to bring Hadoop into Windows Azure is about giving you the ability to take advantage of those processing capabilities for this unstructured data that you may have already, or data that will start to be created. It's a fully managed service. You basically walk up, ask for a Hadoop cluster, and we hand you a compute cluster capable of running the Hadoop infrastructure with MapReduce, HDFS, HivePig, etc., against data. And that data you can bring up and put into HDFS on your own, or you can actually just run it over data you have in Windows Azure blobs. We've done all the integration work, so you have a JavaScript console environment right out of the portal. It's very simple to get up and using and playing and experimenting with right away. But more importantly, we're doing the work to integrate this into the rest of the Microsoft data ecosystem. We're building an AODBC driver, a Hive ODBC driver, so that as you stand up Hive table views over the data that's inside your Hadoop streams, you can access that through anything that can connect through ODBC. And we're doing work to integrate that Hadoop ecosystem into Excel, so it's very easy to allow people who have the Excel skills to also start to just dive right in and understand the data that may be in Hadoop. The stage we're in right now with our Hadoop work is in preview. We have MapReduce, HDFS, Pig, Hive, streaming, and a bunch of the other parts of the Hadoop ecosystem available as part of that preview. Our goal is to complete that and get that into production this year and make this ability to process all kinds of data in that infrastructure possible for everyone, and to really mainstream that for everyone. In our particular demo app example, what we've done is we've turned on enough logging in the system, so we're collecting usage information, how it is that our users are using our expense app, so that as a way to maybe learn how the application is being used, as a way to gain the insights to improve the application. And so here, we'll take it from here, and Div will take it from here, and see how we would do that.
Okay, perfect. So we've gotten a request here at Contoso that they want us, since the expense reporting application is so popular, they want us to go ahead and localize it. So what I'm going to go ahead and do is try to take a look at these log files and see if I can use Excel to try to figure out where all the users of my application are coming from.
So you can prioritize which language to localize into.
Absolutely, get the most bang for my buck. So the first thing I'm going to do is open up a new in-private browsing session, because I don't want all my relational demos to get jealous of this unstructured storage stuff. And I'm going to go www.hadoop on Azure.com. And I'm going to go ahead and log in. And let's take a look at what this actually looks like. So this is Hadoop on Azure at live.com. And yet another password. And let me log in and take a look at what I see here. So a couple things. Here's my Hadoop cluster. Let this load up. So a couple things. So first thing I did previously was I went ahead and I clicked on Open Ports. And let's look at what this does. I opened up this ODBC server port. This will allow me to go ahead and use Excel to go ahead and connect to this and to begin to run queries on this data that I have up here. So that was number one. Number two, let me go back here one more second. Let this load up. An Azure elephant never forgets. That's actually kind of funny. If I go ahead and click on Manage Cluster, I had previously also gone in and set up something called my Azure storage volume. Since all these log files are stored on in an Azure Blob Store, I had to go ahead and make the connection between Hadoop and my Blob Store. To actually go ahead and see how that actually works, let me go back, wait until this loads up, perfect, and let me go into my interactive console. So the first thing I want to do is just run a quick JavaScript query to see what data I have out here inside my Blob Store. So I'm going to do a ~ls asv:\_ service logs.
If you're not familiar with Hadoop, this is currently the state of the art of how people are managing and knowing what's going on with Hadoop. Of course, we're building into the Microsoft Hadoop distributions a whole new set of tools that are much more familiar and much more capable.
Yeah. I don't want to give away the rest of the demo, but for somebody in Excel, they're not going to have to do this, That would be too high of a bar for an Excel user. Not to disrespect the Excel users. Okay, so the next thing I want to do is I want to go ahead and add some structure to this unstructured data. So to do that, let me go ahead and copy out a quick table create that I had previously created. Copy this, paste this in here. Let me click evaluate and explain what is actually happening. So unlike a relational database where the schema enforcement happens at write time, this happens at read time. So when it goes ahead and reads this data, it's going to go ahead and apply the structure to it. It went ahead and completed. So let me actually go ahead and take a look at what's actually inside these log files. Let me copy that out. And put another query in there. And I'm just simply selecting from my service logs. And we'll give this a couple seconds to run. Notice that this looks a lot like SQL. It's nothing new to learn. There's little variance in HiveQL versus SQL, but it's nothing new you really need to learn. And what I could see here is it's a typical log file. I could see a get request to my expense reports application. I could see the IP address, and somebody's using Chrome. They haven't figured out IE is better. So these are the real log files for my application. The next thing I want to do is let me just grab one more query, and let me paste this in here and explain to you what it exactly is doing. Paste. Let me click evaluate. So what we're going to go ahead and do is we're going to create a new table. We're going to go ahead and go over all the service logs. We're going to create a new table that's going to aggregate all the countries and users and where they're coming from. It's going to do a count, and my destination table will simply have country and hit count, and that's it. So while this is running, I had previously run this, and let's actually go look at those results. So to do that, let me pop out and go into Excel. And notice under my Data tab, I now have something called a Hive pane. I had previously downloaded and installed the Hadoop add-in for Excel. If I click on my Hive pane and I enter in my cluster details, let's just call this demo. My cluster is Hadoop cluster.cloudapp.net. Cloudapp.net, my favorite domain. And my username is Hadoop user. And I'm not going to tell you what my password is because it's a secret. I'm going to hit enter. And let's just give this a second. And it's logging in, and it's just logged in. So I've now established a connection from Excel up to my Hadoop cluster. Let me grab one more query, and let's take a look at what this is about to do. Let me go ahead and paste this in here and execute it, and let's have a talk about what exactly is happening. So I chose to actually go ahead and enter in my own HiveQL query. If I was a less experienced user, I would have the ability to go ahead and actually choose my objects, choose the different columns of those objects, add some criteria, some aggregates, some ordering, and it would have gone ahead and built the query for me automatically. And I would have just been able to go ahead and execute it. This is going to take a couple minutes to run because, you know, elephants are slow to get moving, but once they keep moving, they're unstoppable.
That's right.
So let's just give this one more second. And so what it's doing is going ahead, making the connection to Hadoop. It's pulling all this data back, and it's going to pull me back. If we look at the query, it's going to pull me back the country and hit count from top countries, and it's going to order by the hit count descending, and it's going to only pull me back the first 10. And let's give this one more second. I know it's still, there it is, perfect. So it's now gone ahead and pulled back all these results, and I can see the country and the number of users that are coming from that country. Now, using the power of Excel, I can simply just go ahead, highlight that, and say insert. Let me go ahead, I don't know, let's do a pie charts. Let's do that one. And now I have a visualization coming from Hadoop of all the different countries that people are accessing my application.
Looks like Portuguese is next.
The Portuguese is next. So that's it.
Great. Thank you, David.
All right, take care.
So over the course of the last hour, we've shown you the breadth, the spectrum. We started talking about fully compatible infrastructure that comes as you subscribe to VMs and you use infrastructure as a service. We've also talked about platform as a service and what it means to have fully managed services, and that we're having relational key value pair and blob storage capabilities as part of the data platform overall in Azure. And as we continue to evolve the Azure platform, we'll continue to fill out all of those capabilities. Those managed services, it's key to what the cloud is about. The breadth of data types and how you will ultimately use and consume this is what it's about. And a lot of what you saw in the demos, if you're paying very close attention, symmetry in the programming models, access patterns and programming models and tools that you're familiar with today, but then get you to your applications to embrace new scenarios and embrace the cloud scale and take advantage of that right out of the gates. All that put together lets you start to evolve and take advantage of the cloud really on your terms. With that, I'd like to thank you for attending the Cloud Foundational Sessions, and have a good TechEd. Thank you.